Good afternoon, ladies and gentlemen. Welcome to the Munich I CEO Summit. I'm very happy to be sitting here with the superstars, rock stars of the robotics industry. I'm only a little moderator here in this illustrious round. To my right here, I've got Professor Sami Haddadin from the University in Munich. Then we have Thomas Hain, who's the founder of the Hand Group and United Robotics Group. Then we have the absolute superstar here, just received the Nobel Prize for Robotics, I've heard yesterday. That's Melonee, who's the Vice President of Robotics at Zebra Technologies. Then we have Dr. Alwin Mahler, he's the CEO of the German superstar company in the robotics industry at the moment, Franka Emika. I got to they sat down a different way to the way I've written down their names. Then we've got Dr. Michael Super, who's the MD of Roboception, and last but not least, Dr. Olaf Munkelt, MD of MVTec. Twist the other two around. Okay, so our topic this afternoon will be seeing and feeling the world, unlocking perception. When I read that, or when I talked to the people about it, I thought it was like a Carlos Castaneda novel that I was going to be eating some visionary substances here so that we could see what we're talking about. But what we're really going to talk about is how machine learning, vision, and robotics pave the way for the next level of automation. It's obvious that progress in robotics and automation will be very much driven by the capabilities of machines to see, feel, perceive their environment. Only then can we make them behave more autonomously and get people to accept them naturally in direct communication and interaction. Our talk today explores where we stand in this quest, what exciting new possibilities are already on the horizon, and what obstacles we still need to overcome to take robotics and human-machine interaction to the next level. The first broad topic area that we're going to talk about will be the theme of social robotics. This aims at making communication between humans and machines easier, more appealing, more natural, and more effective. The first question I have for the group is, how does social robotics come into play when we want to increase perception? And don't say take LSD.
I may start. Well, Michael and I, we had a conversation just before that talk, and I said to him, by the way, do you know what social robots are? And he confessed no, and I said, I also don't know. So you hit, so to speak, at least me very hard with this question. And then looked a little closer and found that perception can also be read in a way that it's the way how we interact. This is the way how the interface is designed between, say, a mechanical machine or an electromechanical machine and the user who's using it. And in that respect, I think if you look at the HMI, at the human-machine interface, I think that there is a lot of technology which allows you to say this person is in a good mood, in a bad mood, is smiling, is angry, is hungry. You can use sophisticated deep learning technology for this. But what do you do with this information? So I'm not really sure that this really will give us a hint what to do, what the machine then has to do. So there's something missing in my mind, but we are few people on the panel here.
I think one of the things is that when you look at like mobile robots, right? They're actors, they're agents, they're independent. They are taking action, and they don't have a machine interface typically, right? They're taking action near you, around you, and I think you can do a lot of and gain a lot of goodwill with people by having those robots follow the social norms that we all act on every day. So we act on a large set of unspoken social norms and rules, right? And many of them mimic our rules of the road and things like that, but there's all this other etiquette encoded socially within us. And so I think that when you look at it, the first thing is one, semantically identifying the world, and then encoding behaviors in our machines to act on that semantic identification to then try to replicate. I would say that we're not at that point yet where we can, ideally replicate, but try to replicate some of these social norms to make the interaction between people and robots more frictionless. Because right now we have a very high friction rate. Like, if you look at the last 20 years of robotics research, we have been creating algorithms that are based on sole agency. Like, I am an actor and the whole world is about me. And that's the definition of robotics today. Like, I don't care about anything else because I'm planning in a bubble in which that's an object and that's the place I can drive, not that's a person, that's a box, and that lack of notion of the semantic world creates algorithms that are just like A-star, here to there. I don't care how I do it.
I mean, being at Automatica today and feeling the vibes we have here going through the halls, I think we certainly have achieved a new level of automation. If you take the significant advances around computer vision, or if you take machine learning, the changes, especially, and coming to your question around the human-like tactility in the interaction of the machine and the automation, we can have the machine supporting us. I think we have the potential to revolutionize with that industry production. What do I mean by this? I think this tactility allows robots now to be similar than if you and me would do tasks, feel it, and get the sense in the interaction with the robot. And you can solve totally new tasks with that. And this is all today not needed, to your point on how to interact, to program anymore. You can do this very intuitively using the robot to help you get a task set up and change the way we can therefore automate many more tasks and going beyond what we can do today in a very intuitive and AI-supported way, similar than we see platform usage in the consumer area since many years.
I mean, there's also, absolutely, I can only kind of support what has been said. What is interesting about kind of the question of social robotics and perception is two ways. So it goes from the human to the robot and from the robot to the human, and what does the robot perceive is another question. So I guess what is one of the core questions, and you can see this addressed all across Automatica right now, is exactly to make use of all these building blocks we just heard. And the next question in the social sense is, if we see these technologies, can humans perceive them, or what's the perception of the human regarding that robotic system in front of it? Is it the classical automaton? Is it the classical positioning machine? Or is it becoming something more? Is it becoming an intelligent tool? Or maybe in the future, is it becoming an intelligent agent that with its agency interacts on a more abstract social level? So I think we have opened the door with these new robots that have, kind of new bodies, you could say, new senses. So they can see, they can feel, they can grasp the world, right, in the form of in the core of the meaning. And now the question is, can we, with all these new algorithms and new ways of creating smarter machines, create a perception also on the human side to make this a more, becoming a partner, a more symbiotic relation? And how can we nurture that? How can we design that is one of the big questions. And I guess there it really becomes almost a social question. I think this was also an implication of the question.
Yeah, from my experience, I have 30 years experience in integrating robots into the industrial field with the Hahn Group. So we implement more than 1,000 robots per year into industrial environment. And I have started 30 years ago with the generation 1. From my perspective, generation 1 is a 6X robot. And then we came to generation 2, cobots, robots which work together with humans. But I think now it's necessary to find generation number 3, robots who work for humans, robots to assist humans. And I think this is a totally new task, and this is not our home turf from today, but this needs to be our home turf for the future, because in a social environment, nobody is trained to work and to live, to be with robots. We need to create robots which fits exactly in the human behaviors. Robots with special sound movements, some signs to get in contact. And I think this is the new task also. By side of all technical tasks we have to fulfill, we have to find also the way how to communicate with the humans, which the robot should only assist. And everybody is scared having robots with AI doing their own decisions. No. I think this is nothing we have to work on. We should bring robots into the field where robots only assist, but always controlled by the humans by side.
That perception, this social interaction, is there somewhere in particular at the show where you've seen that today?
I mean, I think you have to differentiate between what is really now there, what is, let's say industrial reality. But I think social interaction between humans and machines in general is I'm not sure there's such a big gap anymore. So we carry around our small AI machine with us, right? So and now more and more they become physically embodied, which we then call robots. And I mean, some of us have many robots at home. More and more are kind of engaged with them also in a more complex pattern than we see in spot welding and painting. And I think we can see already many robots, especially in the Halle 5, right? This is 6, if I'm not mistaken. I think in Hall 5 we can see many robots interacting with humans in the wildest sense. And the question is, I guess, do humans accept it? And is it useful? I think this is one of the core questions. So it's not so much about, there's always this discussion, should we replicate human behaviors or should we kind of, substitute them? No, on the contrast, yes, we should assist, but in particular, we should build machines that are supportive, that are useful. People accept them. Why? Because they are useful.
Yeah.
And I would say that some of that is like a bifurcation between the world of the fixed and the world of the mobile. Because I think one of the things that you're seeing here is that when you look at social interaction of the fixed industrial robot, the types of interaction that we talk about is human performing task on robot. Whereas when you're in the realm of the mobile, it's robot acting as an agent in the world independently of a human. And in mobile, we're already tackling a large part of this problem. Like at Fetch, we've implemented large swaths of social behaviors on the robots that have increased their efficiency in navigation by 50%. I'm actually going to talk about this tomorrow at the summit, about how as you reduce that friction between people and the robot as it navigates through the world and acts as an individual in the world, you actually see an increase in efficiency because the people don't do that awkward dance that we do in the hallway with the robot anymore. And it's a well-known thing. I mean, robots, they create friction, right? They're very greedy right now in their algorithms. Almost all robots are greedy. I mean, that's what we've designed them to do. But if you look at the way we interact with each other, it's more of a social contract and it's less greedy. It's more an agreement of how we'll behave. And we're starting to do that in the mobile world. And I think if you look across many of the mobile robots out in the world today, you'll see more and more of these behaviors being pushed out because it's just the right thing to do from a ROI and customer perspective.
But I think this is exactly not it's not fitting into the social environment, because you asked the question, can you see that robot already? Yes, you can. Aldebaran is launching in October a new food serving robot for restaurants, and you can see that here in A4 at United Robotics Group. And this robot, or these engineers of Aldebaran, they took days and months to create the right movements for for the behavior into a restaurant. This is not only going A to B with looking at the obstacles. This is much more, because this is needed. They had a sound designer working for them to create a special sound for this robot in this behavior of restaurant. I was not aware of that. When I heard that, first I was a little laughing and said, okay, sound designer, is this really necessary? Yes, it is, because we don't want to have a machine just moving around our beer or our plates of food. I think this is exactly what we have to take care of in the future.
So it's not just the sense of vision.
Yeah. I can very well see ourselves now being at an inflection point where we can use robots similar than we had 10, 15 years ago, as we all observed in the consumer area, platforms evolving. You just interact with them. You have all supported by artificial intelligence, helping you to optimize tasks, to learn tasks, just to use it in a way that now will allow that to broaden the usage, as we have seen 15 years ago in consumer internet, and then just make it more intuitively accessible for everybody. And today we have the tools now and the technology ready that we can also get this into the production environment. And I think this will be very exciting times to see that for all of us, and broadening the market, broadening the scope of usage, and for us just to, no matter what is behind, it will be all, of course, AI based. It will be more human interaction. It will be collaboration. Perception will play a role. All those data points will get into it. But I think in automation, the most fundamental human-like differentiation will be this tactility moment, because this is something like you and I can do things, as I mentioned earlier.
But I guess what happens if you can't touch the robot, or you shouldn't touch the robot, or the robot shouldn't touch you? And I think there's a lot of interesting work going on. Like at CVPR 2 years ago, there was the ability to basically rationalize and watch YouTube videos in like bulk, and then translate that into human behavior or robot behavior.
Well, I think you're hitting it right. I think safety is a key point on all of this. And that's why we were very happy, and you can come to Hall 6 to see Franka Emika, our TÜV certified certification for safety. So you can let the robot know that you don't need to, you cannot get close to it, and it will stop automatically. You can program the robot with some visual ceilings where you can say, well, don't get closer, and immediately the robot stops. So I think this is very important also to make interaction, as you say, with the robot safe, and we all feel comfortable doing those things.
Before we get too deep into that, can I come to the next broad theme that we're going to cover? Can robots truly understand their environment? When we talk about robots perceiving the world, what does that mean exactly? What level of understanding do robots currently have? What will they have in the future, and what will they never attain?
Yeah, I mean, like generally speaking, I guess the perception of the whole world as such, that's even not something that the human can actually really do. It's usually something that should be considered task specific in a sense. And here we come to the problem, because the robot should be useful. So who describes the task and who describes the subset of things that the robot should be understand? Because I mean, it's a greedy thing that was already mentioned before. So it's still, robots will be operating in a sense of envelope, what the task is, what to expect, what the interaction should look like. So I think that is something, it must be accepted to be useful and must understand the things so that it can perform useful operations. And I think from that perspective, we can level it a little bit down, because there will be no such robot, like generally speaking, that is doing the kitchen work, that is doing the serving in the restaurant, or doing a delivery service somewhere else. That will not be the same robot, and potentially not with the same perception skills. So basically there's a subset that everybody should have, like not detecting the human as noise, but as something that is interacting with you. So that's the first step. And then moving onward to that, what is relevant information, so that you have the right data set for that, the right subset for that, to actually be useful. So that would be my initial state on that.
I don't know. I think autonomous cars have made a huge
Yes.
headway in large-scale semantic segmentation of the world. I mean, if you look at most of the leading autonomous car companies, they do very large-scale segmentation. Everything from that's a stroller to that's a person to that's a dog to that's a thing. Now, what they do with that semantic classification is not clear yet. But I think that the state of the art for semantic classification is very good. I mean, and we can do it in real-ish time these days. I mean, the biggest challenge that we have in many ways is the labeling effort and the data validation. But I think that our issue today is not can we say that that is a person. Our issue is now that we know it's a person, what do we do with it? Yeah. And I think that's where we're struggling as a community, because as you were saying, the challenge then comes down to the task and why is it relevant to even know it's a person as part of that task, and why do we care?
Yeah. And to your point, I see the perception, and I think it's a great analogy with autonomous cars, and you see, you know, the radar around those things. Similar than if you give the robot a visual interface to it, it also uses those data points to integrate and make it even better, to optimize tasks, to get it into the platform and use it to make things more accessible and easier for us. And robots these days, and as we have seen, you probably know the famous example with putting a key into the hole, a lock, and then, you know, robots learn how to open that. And you see all those visualization are data points to learn those tasks. And you can very well imagine with that example, it's like a child would learn the task. The robot can do that in 3-4 minutes, and then you have an app resulting out of this. And with this, you can imagine having thousands of apps once, as you have on your phone today, just using all those tasks to your benefit, as if you would have basically done an apprenticeship now in the automation area.
And so just, I think what Melonee and Alwin are saying is truly important, because knowing and understanding the world in robotics is not like in the classical age of information to store data or maybe kind of abstract knowledge, but in the age of action, which is the robotic age, it's about, I mean, understanding the world means how to interact, how to manipulate, and how to learn with the interaction of the world. So it's not just, you know, a database. It's, you know, the interaction with the world itself is creating the knowledge. I mean, if you think about mobile systems, it's not about, you know, you create the map, but then what do you do with it? You navigate, you move. So, and how to move. This is now where this is where it becomes real. This is where it's not anymore a metaverse, it's a real physical world. And if you grasp something, I mean, think about all our kids, I mean, how they learn how to interact with the world. I mean, they grasp and then in the end, they become piano players or musicians, and it's amazing what they can do. And how can you transfer, and how can you materialize this knowledge into robotic systems? So this apprenticeship question is, I think, truly fundamental, because in the end, you cannot just observe the world and understand, okay, this is how it works. No, you just observed it.
I think to add to that, I'm totally on your side here. So robotics is physical interaction, and that's more than a label. So we can't, like, if you label the data, this is whatever, it doesn't mean anything behind what can be done with the thing, how can you interact with the thing, how you can move it, and whatever. So robotics is always physical. This is why this labeling thing may help in the machine vision, but it may not help in the robotics scenarios in the end. So we have to really think about how we generate the training data for these kind of scenarios so that they are general enough. And covering actually the action, right? Not only the perception. So perception action loop, we are speaking about it for decades, but it becomes even more relevant for these complex interaction tasks.
Yeah, and I think that if you look at the next frontier in robotics, and it's always going to be the next frontier at the rate we're going, is we've been spending the last, 40 years of AI, basically pursuing this hope of learning to learn, because if you look, every decade or so, we think we've stumbled on the thing that is AI. Like in the 80s, we were like optical character recognition, the pinnacle, and then now you use it to cash your check, right? And so we are constantly striving for this thing that we don't even realize that we do, right? Like much of our education is centered around not actually teaching us things, but the skill set of learning to learn. And we do it in a very brutal, unorganized fashion, which we do rote, and then we do non-rote things, and then we go to college, and then it's an exploration space. But we as a community still haven't stumbled upon this logic of how we teach machines to learn. Like we have no problem teaching them to learn a thing. You know, today we can say, here's a whole bunch of data, and one of the bigger challenges that we have with like learning in general is one of the greatest things about people is our ability to infer. Like if you take a giraffe, like you drew a picture of a giraffe and you show it to a 7-year-old and you say, this is a giraffe. And then you never show them anything else, and then you take them to a zoo. They will walk into the zoo and say, there's a giraffe. And we today struggle with those types of inference and making those types of lateral connections within machine learning today. And so we've got a long way to go, but I think that's what we're all aspiring to, and we're not even at the cusp of understanding how to make those kind of inference engines that allow us to make those logical leaps and learn against that.
I mean, coming from those thought models out of Silicon Valley, I found it amazing now just entering the robotics world that those data analytics and, you know, everybody after Silicon Valley lives into deep learning type of models. But here, interestingly enough, it's the opposite, that you go with collective machine learning and you go much faster to results if those machines learn from each other and then can fulfill a task, which you can very nicely see in graphs and experiments where you have the curve and collective machine learning going very fast up at the beginning, versus in deep learning you need thousands of data points and then only you get there. So this fundamental change, I found really amazing, that this collective machine learning will allow us really to get into that supportive tasks mode, which then allow to get those apps and all help us to get into this model to easier access this automation potential.
When we talk about modes of perception, vision, machines that can see, sense of touch, haptic interaction or feedback, hearing, listening, understanding, why are Siri, Alexa and Cortana not on the factory floor when they are already in the living room? And which of these perceptions will be the most important, or will we always need to combine them?
Good question.
I think this it goes a little bit back to what you said, to the other question. It strongly depends on the task. For some tasks you don't need any vision because you know exactly what you have to do. For others you need it. There are robots with force control, there are robots with no force control, but I think this really depends heavily on the application. Siri, Alexa and Cortana, I think it's a good point. They probably see them in the service robotics industry because people are using this already there. So this is about acceptance in a certain application area from my point of view.
I would say that Siri, Alexa and Cortana all cheat. I mean, they abuse the fact that they're in a controlled environment with a low noise floor, right? And so until we can build technology that can deal with a noise floor like this, right? Like all of this background noise. I mean, people's hearing fidelity is very cool, right? Like we have the ability to zero in on certain frequency ranges, certain sounds, and we're very good at pattern detection. And it's something that if you look at those devices, they're cheating in some ways. And they're also cheating by the fact that there's lots of mech Turks behind the scene. When Siri falls down, people pick it back up. And we don't talk about that much in our technology. But the cool thing is today you're seeing more and more companies having like kind of human quietly in the loop for manufacturing tasks. And so maybe eventually we'll get there, but natural language as a way of interfacing with robots in general right now is just super clunky. Like, you'd end up like screaming at the robot. It just wouldn't be much fun.
Yeah, and then there is the, next to the fact that you don't have the mature technology yet, I think that's kind of basically what it is. But we also have the problem, which is a really, it's a big hurdle that is not easy to overcome, is the data protection. We're in work environments. We're seeing data that is personal data of workers. We have humans and robots interacting. We talk about social interaction. Yeah, but then it is kind of data that is related to the individual. So there is also the question, how do you use these kind of, personalized information channels without violating GDPR and other obligations we have?
I also would like to come from the use case. I think the Siri model is like a consumer use case where you want to interact on those things. If you translate that in our robotics world, there are other key data points you need. I mean, we talked about vision, that you have the machine support by vision things, but I think the most decisive change is not only that we have this platform now being able to be rolled out, but with this tactility get into new areas which cannot be automated so far. And that brings us to and probably some of you have also thought about this during the COVID times, during a fundamental question of how can we make sure that our production stays local, that the supply chain stays local, that we have local workforce being secured. And I think now with the idea of bringing productivity gains with those robotic platform services locally here in Germany or other industrial countries, this will allow us to secure our production here and to also with that secure our local workforce and even have something against the shortage of skilled laborers with all those things we just said about the apprenticeship.
Yeah, I think in general it's always a combination of sensing technologies that you'll be using. I think that for me, the most important thing is always that you keep the information consistent. So, I mean, you can use a lot of channels, you can use force, you could use sense of touch, you can use vision, but in the end, it has to be something that's consistent because that's something in collaboration with a human where you see inconsistencies in behavior based on signals, sensors, and so on. I think this could really be an issue where you would basically say, I'm leaving that away if I can keep it in a consistent way. And I think in images, you have ways to do this. In force, you also know. But usually the combination of both and a reason for a way, usually it's after each other. So vision comes first, and then you do the sensitivity. Seldomly it's the same time, so you don't avoid this consistency issue. But I think that is kind of important when we talk about this acceptance and behavior that the robot should show.
I do think, though, there is some downside to some of these attributes that we're talking about, because when you look at robot usage, like sound, for example, and it's emanating a sound, right? Like worker fatigue of certain sounds becomes very much a problem eventually. And the question is as we add some of these things, haptic feedback, touch interaction, things like that, will that also become frustrating, uncomfortable, things that sound like a great idea, but then when someone's doing it 80 hours, over 2 weeks or 3 weeks, like that might become an unexpected burden on the user. And so I think we have to be careful the way we think about the implementation of some of these capabilities, because they do impact the worker and how they tolerate their work environment. I mean, as someone who makes mobile robots, when you have one robot that's going boom, boom, everyone's like, oh, that's a pleasant sound. When you have 80 robots doing it, all the workers are like, can you please shut that off right now? And so I think those are the types of things that we have to be very careful about thinking about our design and our human factors and the impact that they have on those people.
I mean, in a way, what Melonee is pointing to is, I think, really the distinction between what sense do you need for the robot to be useful, to do something that can be productive, that can be used in manufacturing or whatever, That's kind of the skill of the robot. And then there's a second dimension, which is the interaction, right? So this is really the human in the loop question. And I think we need to make sure that we understand the distinction, because in the end, I mean, you might want to have sense A to do something that becomes useful, so that the robot is doing some valuable piece of work. And the other dimension could be that this feedback is just not useful in the human-robot interaction sense. A robot poking you all the time is a pretty annoying thing, right? But a robot with a sense of touch that is able to do gear assembly, I think that's a pretty useful thing. So I guess this is also kind of part of the picture that we should talk about.
Well, and some of us here might not be in a position to program things, and these days, with the intuitive usage of a robot, you just show two positions, press on an app like you would do it on your phone, and off we go. The collaboration is very easy, and so I think the human deciding how to be supported and having this in a very intuitive way, helping really to get in automation area, which we are just at the beginning.
We've talked about sensors, data security, and machine learning a couple of times now. But for real perception, sensor technologies needs to be part of a more complex system of planning, learning, and following a purpose on the side of the machine. The sensor data needs to make sense for the robot to trigger sensible action. Where does machine learning come in, and how much general intelligence is needed to turn sensor data into real perception?
Maybe I start on that, and then you jump in. So, I mean, we mentioned already in the beginning that robot is about physics. So physics, physical interaction, true position of things. So I think where machine learning can really help us here is, especially because in robotics we are in many cases still on small data, not on really big data. So we have to get data, simulation data, training data from the simulation, from things that we can generate automatically, and then extend that by real data that we collectively are able to label in a proper way. I think in the robotics domain, in many cases, we already have ideas on how things work. We have some models, so we should not throw that all over again. Take the model knowledge that we have and use the machine learning as a parameter finder, so to say, that allows us to parameterize the things that as a human are very hard to parameterize on the development side for sure. And that makes then the right skill set in the end. So we should use the model knowledge we have, expand it by simulation, and then comes the real data in the end. And if we do it in that way, we have a better grounding, I guess, than if we just start from arbitrary data sets labeled by someone who we don't know what he did, and something like this. So I think that's where the machine learning could be bounded a bit to what we actually want to do.
I think machine learning is the basis of everything these days. There's all platform services like we use every day, and it will become the same for us in intuitive usage now in the production environment. And the smart robots, together with the AI platform, we will be able to really move in advance, getting in numerous tasks, which will be just handy for us to solve and use. And basically, at the end of the day, if you think it, you can make it.
I'm a massive contrarian to all of this. I believe that you should use the right tool for the right job, and if you don't need machine learning, really, don't use it. Like, if you can draw a line from point A to point B, why the heck would you spin up like a cloud platform and like try and learn how to draw a line from point A to point B, right? So I think that there are applications in which machine learning makes sense, and it has value and it adds value. But I think that we have become way too obsessed with the hype of machine learning. Like, if you can use linear regression, use it. Like, it's more cost effective, it's more stable, it's more reliable. Like, those are things that are good in making products that protect people and do the right thing, and also probably don't have problems with PII and GDPR. I mean, I fundamentally believe that there's a right place and time for the usage of the technology, but we've gone like we've jumped the shark on this one. Like, we need to chill out, figure out what it's good for, and use it appropriately.
I think after that answer, I'm going to skip my question on deep learning.
But actually,
What was the
we
question?
didn't
That
say
sounds
anything
interesting.
else, right? So we have to make sure that we use the right tools.
Yeah.
That's what you
Yeah,
said, and I mean
exactly.
that's true, right?
Yeah.
Robotics use tools, and you need to use the right tool, and machine learning AI is one of them, among many others that we used in the past. So as I said, you don't have to learn kinematics, right? That's a model-based thing. Work with it and do it. But there are some things where you don't have a model, and these are the things where you should use the tool, so to say. Yeah.
I just want to give you a very practical example. Today we had a big strategic potential customer on our booth, and we had an implementation where the tactile robot took a screw, put it in front of a phone, who then was able to scan the screw and learn whether that screw was produced exactly. And this is normally something which needs to be done in a separate way and was two separate processes in automation. Now, together with the visual inclusion in that process, with the data around it, and with the basis of the artificial intelligence making the evaluation on it, you can just have this in one flow.
Maybe to also break a line for machine learning. I mean, of course, if you would have said deep learning, I would also be much more passive on my answer. But I think what is important is that we as a robotics community, we have been pretty stubborn about deep learning, right? We were kind of like, no, we're engineering, it's safety, it's integrity, it's actually efficiency. We don't want to have billions of data sets for controlling a motor, let alone kinematics. And I think this is the great thing about the robotics community. We know that and it works. And now with this basis and this understanding that this is not necessarily the solution, the standard, hyped way of learning, but the clever way, how to fuse models with learning and make, this interaction with the world be part of a learning process. I think this is really where this super interesting challenge, but also opportunity for robotics. Why? Because robots can actually actively interact with the world, and together with the human, you can share this question of what do you want to learn. That can be the process knowledge coming from the human. So what are you supposed to do? But the how, within this boundary box, I think, Michael, you were basically kind of pointing towards it, which I liked a lot, the idea of parameter search, right? So now it's just finding the right set of parameters, and then the robot is able to do it. It's a very fundamentally different paradigm than, just enumerating data and then learning a classifier. So this is a much smarter way of doing it, and I think robotics could be the field where this type of, next level machine learning can really be a breakthrough.
Okay, I've got one more topic area, and that's the area of safety. The more autonomous systems are becoming, the less predetermined are their actions, which raises the question of safety and ethics. Where are the pain points regarding the safety of perceptive autonomous systems? What solutions and approaches are there to ensure safety? How can we deal sensibly with privacy protection when the systems record more and more what is going on in their environment? You've already addressed that.
Maybe I can take this on, because we came from, as Franka Emika, from a leading position in the research world, where people were just using us and doing the experiments, advancing the platforms and the systems. But we clearly realized that in order to get to a broader automation and accessibility in the industry area, you need to be certified in safety. So we made a big effort in developing a system now as the first ones to have really this tactility and this, what I described, the safety environment available for the industry, and have a TÜV certificate here, which will then, in our view, will be some sort of an official entry ticket into the industrial floor and a broader automation.
I don't know. I've spent the last 5 years working on national standard in the United States for mobile robots, and I would say that there's two sides of this safety coin. One is, for a very long time, we've taken a very rigid view of how safety can be achieved, functional safety can be achieved. And I think it's hurt the industry a little bit, because one of the things that we encountered when you look at something like 10218 or 1506, they took a very strict line that everything had to be PLD, even if the arm was this big, right? You know, like a little baby arm that could go boop, but it had to be PLD certified, right? And I understand the caution because the end goal is to protect the end user from massive arms that could drop a car on them, and you know, providing methodologies to ensure the safety of those devices. But if you look at where we need to go from a safety perspective, we need to write standards that are more encompassing and rely more on the competency of the vendors to perform hazard and task-based risk assessments that drive to a performance level rating for the technology that's appropriate, such that we can build devices that have no chance of killing or hurting someone, and have affordances and functional safety affordances that make that platform safe, without requiring them to put yellow lasers all over the robot. You know, it's a teddy bear robot, and it is made of fluff, but it has to have a PLD SICK laser inside of it, you know, and like that doesn't make sense, right? So we have to be more practical in the way that we create safety standards, and then we have to, on the flip side, expect vendors and manufacturers to be more competent in their risk assessment capabilities, because I think for a very long time the standards assumed a lack of competency, and they said as long as we write the standard in such a way that no one can mess it up, no one can mess it up. But that leads us to the path that I've been talking about, where we have safety standards that are so restrictive that they actually impact business and innovation.
Yeah, so when it comes to safety, I think that's really something I need to speak up a little bit, because my dissertation was back then called Towards Safe Robots Approaching Asimov's First Law. So basically my sole existence as a PhD student was centered around this question: how can I develop robots that are as safe as possible and without making over ambitious requirements, but really, you know, being an enabler. And one interesting thing that I found as a scientist always a bit interesting was that in standardization we think that a 1-ton robot, or a robot that has a moving mass of, let's say, 5 kilogram, has the same potential hazard, which obviously, I mean, we don't, in car industry, we would say a Panda, right? Or a truck. They don't have the same safety requirements, right? They have different requirements. So I think one thing that is extremely interesting to me is we talk about collaboration, we talk about safety, but the most important fact, moving masses of robots, is not really the risk classifier, which is kind of interesting. And then also what I guess could be a way to move forward is to kind of give the competency really to the manufacturers, to the experts, because there is more and more competency in the whole risk assessment and also evaluation of human injury. Can you injure a human, yes or no, and how do you deal with that? So I think it's all about safety, and then it's about human injury, right? This is what we all care about. And how can we prevent that? And injury prevention should be our focus. And how do we prevent injury? The answer is not always kind of functional safety, right? I mean, you can be as safe as, I mean, I can hurt you as with a robot that absolutely knows that it hurt you. So it's functionally safe, but it's not human safe, right? So.
Yeah, I mean also like at the moment we're talking about a lot of safety in the domain of like industrial robotics, mechanical environments that we control. So at the moment I don't really see that we can bring a robot arm to a home with the regulations that we have at the moment, because it's really hard to adapt to that, to follow that, and also keep some kind of performance which relates in acceptance, right? If you have a tool that is safe but not performing the task, also doesn't help us a lot. So there's this contradiction. We talked, the robot must be useful, it must serve something, it must do something somehow better, otherwise I wouldn't use it. If safety is the thing that limits it in that case, I mean, that's something that needs to be discussed, right?
Okay, we've come almost to the end of the hour. I've got one surprise question for you. This is the end of the first day at the show. You've all been, like I said, you're the robotic superstars here. You've been walking around the show all day. What should people not fail to see when they come here to the show? And please don't say the product that's on your stand.
I think that they should go to the university section and check out all the great, interesting work that students are doing, and really, I mean, it informs what's going to happen in the next 20 years. So I think it's really worth going and visiting that section.
Yeah. I want to +1 this, and in particular to the AI Society booth, where you, by the way, can of course see also our robots, but it's something which really shows you about our topic, how with data and learning and AI you can really advance things fundamentally.
I was very surprised today to see the university section and how well it was prepared by Messe München. I'm very pleased by it, and I was also surprised to see so many young students walking around. So I was really happy to see this big interest gathering all these young people in here. But I also would like to say that there are a lot of, say, traditional players on the show. There's a lot of, say, standard measurement methodologies to see, and they perform also an excellent job. There's a lot of technology in there, so this would be my other favorite, to walk this side of the halls as well, because the other exciting room is opposite of this hall here.
Yeah, so I basically would say that what we are seeing here nowadays is that it's more than the robot. So there's a lot of applications being shown, things where robots are used. So you can see that in the B4 hall where most of the cobots are, but also look where the classical robot manufacturers, they're showing a lot more of these application business, right? How robots are used. It's not only on the robot at the moment, it's this year a lot what can be done. And I think that is the most interesting thing, what can be done with the robot, and have a look on that, the key manufacturers and then the cobot area. I think that's what you should see.
Yeah, after 3 years, it was time to meet again, and seeing all these young people and students here around, this is amazing, and this makes me very hopeful for the future. Yeah, and for sure, a few companies are gone in COVID, but many new companies are here, new players, fresh people, fresh minds, very inspiring. And if you want to have a fresh beer, come to the booth of United Robotics Group, served by
There's an
first
audience here.
European restaurant robot. So you're invited, come on.
That sounds wonderful. I'm gonna join there. So if I may put my 2 cents in that as a university teacher and scientist, I think what is really great of you guys to acknowledge is that there is so many new young people. They are coming into the industry. I really think that's super cool that you guys are really seeing that. Together with Messe München, we were really trying to, get that bond to academia, to new talents, to really, nurture that environment. So I really can only support that statement. That's a very different automatica from the times, before the pandemics. I think we kind of have an amazing happening. It's super exciting for me, not only to see people, but also to see exactly this transition. For Munich ecosystem, we have indeed tried to really gather around the community and not only, much more think in ecosystems. And the mentioned AI Society that it was enabled by Messe München and Automatica is really this attempt to show what the Munich ecosystem as a whole can do, and not only single research institutes, startups, or companies. I mean, even BMW is part of that. But really, what can we do as an ecosystem? And I think this is one of my key learnings. And another thing that I would like to invite you guys, if it's still possible, I'm not sure, but we're going to have tomorrow the High-Tech Summit, the Munich High-Tech Summit, and we're going to have, amazing speakers like Melonee with us. So she's going to be there tomorrow. So freshly baked Engelberger Award, amazing roboticist, and we've known each other for many years. So it's wonderful to have you again here, and looking really forward to the talk, but also to all the other talks we're going to see tomorrow.
Sami, you've taken all of my last words out of my mouth. So all of you should come back tomorrow, go to the Munich AI Summit, and go and visit all of the things that these people here have seen. I totally agree that the shows today, a totally different show to the first one. I've come to all of the Automatica shows up to now, and this is a much, much different event. So congratulations. Thank you all very much.
Thank you.
Wir sind alle jung. Ne?
Aber hallo.